Hi, welcome to the third Gravity Engine tutorial, where we'll talk a little bit about collisions between gravitational objects. As we always do, we begin by adding a gravity engine to the scene, and then for this demonstration we'll grab two stars using the prefabs we've created. And we'll adjust them so that they're separated in space, -10 and +10 for the x values of these stars so that they're separate. And if we just evolve them at this point, there's no collision going on. We're using a simple integrator, and when they get very close to each other, they get a large force and they get kicked away from each other. And we want to resolve this issue by having the stars collide, have physics preserved, and then we can either have one absorb the other or bounce off the other, depending on exactly what we're looking for. So you'll notice that on each of the models for the stars, we have sphere colliders. And we'll use as much of the existing Unity collision detection techniques as we can. And then we'll add collision objects that the gravity engine understands to augment that. So in order to do that, we want to add to this model a rigid body. We want to use isTrigger, and with regards to the rigid body, which we have to have there for the trigger to fire, we really don't want Unity to be doing any physics because that's what the gravity engine will do. So we'll set the mass to 0, which just makes it very small. We'll tell it not to use gravity, and we'll tell Unity that this object is kinematic. We'll do the same thing to the model on the other star. So we'll add a rigid body. We'll say we want a trigger, no rigid body mass, no gravity, is kinematic. Now this is enough for trigger events to get generated when these two bodies touch each other. What we want to have happen is we want gravity to take over, and so it's a collision between two n-bodies, so we're going to add an n-body collision script. And we have a choice here of collision type, and so in this case the choices are absorb immediate, so the body as soon as they touch will disappear, absorb envelop, when the body with the collider attached to it is completely inside the other body, it will be neutralized. We can create an explosion, which we'll talk about at the end of this session, or we can have them bounce off each other. So for the time being, we'll pick bounce, just to keep it simple. They come together, and they bounce apart. And that will continue. And if we change that to absorb, absorb immediate, let them interact, and as soon as they touch, the body with the collider attached to it is inactivated, as you can see over here, and its momentum is added to the momentum of the other star, so that with conservation of momentum, we had 0 momentum at the start, and we have 0 at the end. You can stop that. Similarly, if you do absorb envelop, it ends up looking like this. What's happened there is because the objects are of the same size, they go through the point where they get a very high force before it's fully enveloped, and so it actually tunnels out. So in order to resolve that, what we need to do is make the size of the body being absorbed a fair bit smaller so it can be fully absorbed before it gets to the point where that high force is applied. So let's try that again, making the first star smaller. And that's a much better outcome. So now we can look at the more complicated option, which is to explode. And in order for an explosion to happen, we need to attach an explosion prefab, and there is one provided in the prefabs folder. So we'll take that explosion and put it over here, and then we'll take a look at what this explosion specifies. So it's a particle system. It's been set up with a particular number of particles. It's got a gravity particles script attached to it so that the particles will be controlled by n-body. And it has an explosion size, and this is a target size. For reasons that I'll explain in a minute, we can't always achieve exactly that size without a little bit of adjustment. The ejection of particles will occur in a cone along the direction of the impact vector, and we can have them all at this velocity to reach this explosion size, or we can have that velocity spread out a bit. A larger number here spreads out the velocity. And then there's a velocity adjustment factor, which after I demonstrate the explosion, we'll explore a little bit. So in this case, and you can see way over here there's an explosion, and it's obviously a fair bit bigger than our explosion size. The reason that occurs is all of the initial particle velocities are determined so that they should reach 0 at that explosion size. But that gives them a fairly high initial velocity because this is a heavy star. And so in that first time step, they essentially go farther than they really should, given that gravity would have been also pulling them back smoothly throughout that time step. It's essentially a numerical integration issue. And it will vary depending on the size of the star and the mass of the star. So as a consequence, we often want to soften that initial velocity a little bit. So if we make it 0.9 and then retry the explosion, it's improved, but it's still too far out. We can soften it to 0.8. Soften to 0.7. And we get a more reasonable explosion. The other field in the n-body collision script is collision precedence. In the event that both of the stars had collision objects attached to them, let's just add one here. So here we have a case where this script says bounce when they collide, and this script says explosion when they collide. And we need to make a decision about which one is actually going to describe what happens, and we do that by means of the precedence. And lower numbers are the winners here. So in this case, I have an explode with precedence of 2. I have a bounce with precedence of 1. When we evolve the system, we get the bounce because it has the lower precedence. In the event of a tie, the tie is broken by using the object identifier number, which is essentially just a deterministic way of picking a winner. That concludes the tutorial on how to add collisions to gravity engine objects. Thanks for watching.